So we want to determine if the mean value theorem is satisfied and then find the C value that satisfies the mean value theorem conclusion. So the first thing that you want to do is you want to notice that it is continuous on a closed interval from 0 to 2 since f is a polynomial. And again, really what you're focusing on is a polynomial. Let's use complete sentences here. Really what you're focusing on is that there's no denominator, there's no radical, and there is no argument for the natural log. So those are the issues that potentially you could have, and we don't have any of that. It's polynomial, so the function is continuous. All right, so the second part is we ask about differentiability. And for differentiability, you want to take the derivative, and here when I take the derivative, I would get 1 plus 2x. And again, as we discussed in class, it's really a question of, do you have a denominator, a radicand, or a natural log? In this case, it is perfectly well defined for all real numbers. You have a polynomial, and so you would say that f is differentiable on the open interval 0 to 2. And again, if you wanted to talk about why that is, it's because you have a derivative that is a polynomial. Okay, so you have a continuous, you have a differentiable on the open interval, so that tells us that the mean value theorem applies. And so now what we're going to do is we're going to find our C value. So remember that in the mean value theorem, you have your f of a, which in this case is going to be our f of 0. So we're going to have 1 plus 0 squared, so we get 1. Then we have to figure out our f of b, which is going to be f of 2. So we have 1 plus 2 squared, so we're looking at 3 plus 4, so we're looking at 7 for our f of b value. All right, so now what we're going to do is we are going to find our, excuse me, our C value by looking at f prime of C is equal to f of b minus f of a over b minus a. So our f of b is 7, f of a is 1 over the b value of 2, a value of 0. And again, the a and the b value are coming straight from this interval, my a comma b. Now, for our f prime of c, if you want to, you can keep it in terms of x, or what you can do is you can say, okay, this is my f prime of x, so that tells us that f prime of c would be defined as 1 plus 2c. And so then we are going to solve for c using the derivative, okay? So on the right-hand side here, we have 6 over 2, so that gives us 3, and then 1 plus 2c. So to solve for c, I'm going to subtract 1 from both sides. Again, we just have a linear equation. So we're isolating c by subtracting 1, dividing by 2, and we get c is equal to 1. Now, before you say that that is your final answer, you always kind of want to just take a little mental note of the interval. So the interval is from 0 to 2, and we see that the c value that we have is an interior point. It is inside, so this c is inside of the interval 0 to 2. Namely, c is an element of 0 to 2. So the c value that we want to pick in this case is c is equal to 1.